Today we're looking at lesson 8-9 on perfect square trinomials. This is your last lesson of 2016. So, we are going to look at factoring perfect square trinomials mainly, and then pretty much being able to factor anything given to us. So here's when you're talking about perfect square trinomials, it would mean that the first term squared makes a perfect square, and then you multiply the inner and outer terms by each other and then by 2, and then the last term would be a perfect square. So they have one option where you have it as plus plus and then the other option as minus plus. So I've shown you how to factor if it's in that form and what your final answer should be. So this would be one answer if it's in this form, and then here's another type of answer if they ask you to factor in that form. So here we have one example. So you notice that the 9, the leading coefficient, and the constant, which is the 16, are both perfect squares. So this matches the perfect square trinomial factoring. So all we need to do is take the square root of the first term, take the square root of the first term, so 9, and then take the square root of the second term, or 4, and since they're both plus, we're going to have them be plus, and so our final answer, if we factor this, would be 3y plus 4 in parentheses squared. Here's another one. This one has 2a squared plus 10a plus 25. Since this is not a perfect square for both the first and the third terms, we need to factor this like we were doing where we had an a value as our leading coefficient, so we had a number other than 1. And what we did for that one is we multiplied the 2 times the 25, and we get factors of 50. And then we're going to end up factoring by grouping here, but we need to get factors of 50 that add up together to get 10. So if you think about it, there's actually no factors of 50 that add up to be 10. So this would actually be considered prime or unable to be factored. So we just put prime as our answer. So here is just an overview of the 3 steps that you want to do when you're trying to factor anything at this point. You want to first factor out any GCFs, or greatest common factors, that you have between the variables and the numbers. Then you're going to check for any perfect squares and apply what we did for the last lesson and this lesson. And then also, after that, if there is any, then you would follow that. If there is not, then you're going to apply the factoring patterns we used with these 2 forms, x squared plus bx plus c, or ax squared plus bx plus c. So we're going to do these 3 steps in the next few examples. So the first thing we need to do is see if there's a greatest common factor, which there is, 2, and we're going to take that out by dividing each term by 2. Now we check to see if there's any perfect squares, which there is. 16 is a perfect square. There's also a minus sign, so that is factorable. So we're going to have x minus 4 if you take the square root, and x plus 4. And this would be our final answer. Here, this doesn't follow the perfect square trinomials, but we want to see if we can have a greatest common factor first taken out, and it doesn't actually look like we can. So we're going to just follow where we have an ax squared plus bx plus c form, which would mean we need to multiply the 12 and the 25 together, which is 300. So we need factors of 300 that give us 5. So we have 1 and 300, 2, 150, 3, 100. We have 4 and 75, 5 and 60, 6 and 50. Haven't really gotten close yet here, so I'm going to keep going. Getting closer here, we have 10 and 30, 12 and 25, and 15 and 20, and it looks like we finally got a possibility here to get positive 5, so we would need to make 15 the negative one, and then we need to group these so that we can have the greatest common factors of each taken out. So we have our first term plus, actually we probably want to put the 15 and the 20, we want to put the 15 first and then the 20. But we have a grouping now of 4 terms, so we're going to group the first 2 and the second 2 and take out what they have in common. It looks like we might want to switch this actually after just looking at it, because we can take out a 4 instead of a 3 if we put the 20x with the 12x squared. So we're going to put the 15x with the 25 instead. So that way we can take out from 12 and 20, we can take a 4 out and an x. We have x left over, or 3x, sorry, 3x plus 5 left over. And then again we can take out a 5 from the next group, and we have 3x minus 5. So we're going to take it out as a negative 5. So let's do 3x plus 5. That will give us 4x times 3x plus 5. I just realized this was supposed to be a negative 15x, so it does become positive 3x plus 5, because your goal is to have the two parentheses to be the same. So you have 2 sets of parentheses here, 4x minus 5 and 3x plus 5. And that would be the most we can factor. Here we have where we have to factor and solve, since we have it equal to 0. So this follows the perfect square trinomial, because we can split it up into a plus 6 and a plus 6, because 1 is a perfect square, which is the coefficient for the first term, and 36 is the perfect square, which is the constant term, so, or the third term. So the pattern here would be a plus 6 times a plus 6, so we're going to put that together as just a plus 6 squared, and that would be our final answer. Here we have some fractions, which we're again looking to see if we can take the square root of these, and 4/9 is able to be, the square root is able to be taken, and then we have a 1 again as our coefficient, so we're going to follow the rule. We also need to pay attention that there's a minus sign here, so it's going to be y minus, and then we just take the square root of 4/9, which would give us 2/3. So it's going to be y minus 2/3 squared. Now if we're solving this, oh, and we need to go back to the other one and solve. If we're solving a plus 6 squared equals 0, we need to cancel out the square sign. So we need to take the square root of both sides, and that will cancel it out. So now we have a plus 6 equals 0, because the square root of 0 is 0. So our answer would be just a equals negative 6. Here we are solving for y, so we're going to put this equal to 0. And again, we need to cancel out the square root symbol, so we're going to take the square root first and then solve. So we get y is positive 2/3. And that would be our answer. Here, these are just more where they've already factored them for you. You just need to solve. So we're going to take the square root first, and we get a minus 10 equals 11, and then we solve for a by adding the 10. So we get a equals 21. Again, take the square root. So we have z plus 3 equals the square root of 26. We're going to subtract 3. So z is the square root of 26 minus 3. So we're going to have to round, which gives us about 5.1 minus 3. So it's going to be about 2.1. And the last one, we are given a scenario here where we need to find the time it takes a ball to reach the ground if it is dropped from a bridge that is half of 205 feet. And we're going to use this equation to help us. So t is seconds, h is height, and h sub 0 is the initial height. So if we go back here, it says it's dropped from a bridge that is half of 205 feet, so the initial height is going to be half of 205, which is 102.5. So that's going to go in here for h sub 0. And then we're asked to find the time it takes to reach the ground, and if it's on the ground, that means our height of it is going to be 0, so we're going to put 0 in for h, and we need to solve. So we're going to just put 102.5 over here and solve for t to get the time, and then we need to divide by negative 16, and we get t squared equals negative 102.5 divided by negative, which is about 6.4, and then we need to get t completely by itself, so we take the square root to cancel out the square symbol, and we need to do the square root of 6.4. which is again going to be a decimal that will round, which gives me about 2.5. So my answer is it's going to take about 2.5 seconds for the ball to drop from the bridge. And that concludes your last lesson of algebra.